So let's show that this is linearly independent. Suppose you have C1 times V1 minus V2 plus C2 times V2 minus V3 plus C3 times V3 is equal to 0. Question: what do we have to show in order to show linear independence?
All C's
C1, C2, C3 are all 0. That's what we have to show, right? So let's see how we can show that. Then C1 V1 plus negative C1 plus C2 V2 plus negative C2 plus C3 V3 equals to 0. What I did is I distributed the coefficients and then I organized it in terms of V1, V2, and V3. So I gather it like that. Now, since we're given that V1, V2, V3, this list is linearly independent, we must have what? If this is linearly independent and you have a linear combination that's equal to 0, what does that force us to say? These are coefficients, right?
Yes.
So for that to be 0, what are we forced to say?
C1, C2.
C1 is 0, negative C1 plus C2 is 0, negative C2 plus C3 is 0. Okay. But then that means C1 is 0, and then 0 plus C2 is 0, and then which means C2 is 0, and that means 0 plus C3 is 0, that also means C3 is 0. So just starting from C1 equal to 0, it's just, if you plug this into the second equation, that forces C2 to be 0. If C2 is 0, then if you plug into the next one, that forces 0 plus C3 to be 0, and then you get everything 0. So you're done. You've shown that these are linearly independent. Okay. So that's part A. Part B. What about this? What do you think? Do you think this is linearly independent? You could try. So let me write in something because I'm going to fail. C1 times V1 minus V2 plus C2 times V2 minus V3 plus C3 times V3 minus V1 equals to 0. That's C1 minus C3 V1. That's negative C1 plus C2 V2. And then plus negative C2 plus C3 V3. Okay, so what does that give us? It says C1 minus C3 must be 0. Negative C1 plus C2 should be 0. Negative C2 plus C3 should be 0. Okay. Does this force C1, C2, and C3 to be 0? If not, can you find non-zero values of C1, C2, C3 that makes every one of these 0? Come up with something. What do you see? 1. C1 as 1. If you put every one of these as 1, they definitely give you 0 without being 0, right? So, that means we failed. This is not linearly independent. Instead, what you can say is that you can pick these to be 1 and it'll be 0. So let's do that. So now we say 1 times V1 minus V2 plus 1 times V2 minus V3 plus 1 times V3 minus V1 equals to V1 minus V2 plus V2 minus V3 plus V3 minus V1. These cancel, so you get V1 minus V1. Oh, that's 0. Okay. Since C1 equals to 1, C2 equals to 1, C3 equals to 1, satisfies C1 V1 minus V2 plus C2 V2 minus V3 plus C3 V3 minus V1 equal to 0. That means this is linearly dependent. Okay? So that's how you show this.